Okay, so the next question that we had was basically you want to find the equation of a line intersecting the y-axis at a distance of 2 units above the origin and making an angle of 30 degrees with positive direction of x-axis. So you have intersecting the y-axis, you have intersecting the y-axis at a distance of 2 units above the origin. At a distance of 2 units above the origin, and making an angle of 30 degrees with the positive direction of the x-axis. So now if you want to find the equation of this line, so you see that your y-intercept over here is 2 units above the origin that means that your y-intercept over here, your y-intercept is positive 2. And since the line is making an angle of 30 degrees with the positive direction of the x-axis, then your m is equal to tan of 30 degrees, which is equal to sine 30 degrees by cos 30 degrees, which is equal to basically 1 by 2 by square root of 3 by 2, which is equal to 1 over square root of 3, which is equal to square root of 3 thirds. So square root of 3 thirds is, so then basically I don't remember the formula really, but we said that basically if let's suppose that your y-intercept is equal to c, for example. If your y-intercept is equal to c, then you will have some point like 0, c on the y-axis, and you have your m. So then you have y minus y1 is equal to m times x minus x1, and since it's basically you can write y minus c is equal to m times x, so y minus c is equal to mx, and so y is equal to mx plus c. That's the way that you write the equation of a line when you have the y-intercept of the line, meaning that c is the y-intercept of the line. So now your y-intercept, your c over here is equal to 2, and your m is equal to square root of 3 thirds. So then the equation of the line becomes y is equal to basically square root of 3 thirds times x plus 2, and that is the equation of the line. So question number 6 is, or you can basically write this as 3y is equal to square root of 3x plus 6, or you can say that basically 3x minus square root of 3, that there's something wrong here. if you have y is equal to square root of 3 divided by 3x plus 2, then multiply by 3, you'll get 3y is equal to square root of 3 times x plus 2 times is equal to 6. And so negative square root of 3 times x plus 3y is equal to, or basically minus 6 is equal to 0. And so you can write this as square root of 3 times x minus 3 times y plus 6 is equal to 0. And of course you can divide by square root of 3 to get it to in the way that they have gotten the equation over there. You can write this as basically square root of 3 over square root of 3 times x minus 3 over square root of 3 over times y plus 6 times over square root of 3 is equal to 0. And then this is equal to x minus basically 3 over square root of 3 is equal to 3 times square root of 3 over 3, which is equal to square root of 3 times y, and 6 over square root of 3 is 2 times square root of 3. 2 times square root of 3 is equal to 0. And that is x minus square root of 3 times y plus 2 times square root of 3 is equal to 0. And that is basically the equation of your line. Question number 7. Question number 7 is passing through the points negative 1, 1, negative 1, 1, and 2, negative 4. So in this case you can use, for example, y minus y1 is equal to basically y2 minus y1 over x2 minus x1 times x minus x1. And so basically you can write this as y minus y1, which is equal to 1, is equal to negative 4, negative 1, 2 plus 1, x minus x plus 1, and that's y minus 1 is equal to negative 5 over 3 times x plus 1, and then you can write this as y minus 1 is equal to negative 5/3 times x minus 5/3, and see how they've written this. And then you need to basically, you can move your x to the other side of the equation, meaning that you can write it as 5/3 x plus y minus 1 plus 5/3 is equal to 0. And then multiply by 3, you will get 5x plus 3y minus 3 plus 5 is equal to 0. And then 5x plus 3y plus 2 is equal to 0. And that's the equation of your line, question number 7. 5x plus 3y plus 2 is equal to 0. So question number 8 is perpendicular distance from the origin is 5 units and the angle made by the perpendicular with the positive x-axis is 30 degrees. So this is also a good question. So the perpendicular distance from the origin, perpendicular distance from the origin is 5 units. 5 units, and the angle made by the perpendicular, the angle made by the perpendicular with the positive direction of the x-axis is basically 30 degrees. So to have a basically to understand what the situation is that, let's say that the perpendicular, there is a perpendicular from the origin, and the angle that this perpendicular makes with the positive direction of the x-axis is basically 30 degrees. Okay, so that's 30 degrees. So if this angle is 30 degrees, so let's suppose that, for example, this distance over here is 5 units. And of course your line is supposed to be perpendicular to this normal. That means that, for example, you would get some line like this with a negative slope. So that's basically what your line looks like, what your line is. Now, in order to have the equation of such lines, what you need to do is basically, we did talk about this a little bit. And that's basically called the normal form. So let me show you how you can find the formula for this normal form, and then we will solve this problem. So about the normal form, so you basically suppose that a non-vertical line is known to us with the following data. For example, let's say that we know the length of the perpendicular or normal from the origin to the line, meaning that, again, in the same situation, you have, for example, some line like this, and that line goes through these axes like this. You have y and x, and there, from the origin, if you draw a perpendicular to this line, it would look like this. And if I call this P, and if I call the angle that the perpendicular makes with the positive direction of the x-axis, if I call that omega, then you would have basically this situation over here. This is again, you can draw a perpendicular here. This is point O, you can call this point A, and that is basically the whole situation. Now if I call this line L, so let's suppose that the line that we want to find the equation of is L. And basically the perpendicular distance of this line from the origin is P, which is equal to OA, and the angle between the positive x-axis and OA is basically omega, as you can see over here. Now there are four different possible positions for this line, meaning that you can basically put it in this position, or you can have it in the second, for example, quadrant, something like this. You can have it in the second quadrant, and that would be, for example, your normal or the perpendicular, and then this configuration would be, and this would be, for example, your omega, this would be your P, and so on and so forth. Or you could have the line in the somewhere in the third quadrant, something like this, for example. You could have your line over here, and this would be the perpendicular distance of the line from the origin, and this would be your omega. This would be your omega, and then you could drop a perpendicular from this point to here, and again, this is the y-axis and this is the x-axis. Or you could have it in this position, meaning that you could have a line over here, and this would be the perpendicular distance of the line, for example, from the origin, and this would be your omega. This would be your omega, and this would be P, for example. Now let's go back to, these are basically all the different configurations of, all the possible configurations of this line with the same setup. So now let's go over here and just concentrate on one of these, because all the other cases are going to be the same story. So now if you have your line in this position, or in any other position, or in any of the other positions for that matter that we had over here, if this is the perpendicular distance from the origin of this line, let's call it P or OA, and if this angle is the angle that the normal makes with the positive direction of the x-axis, if I call that omega, then basically you can calculate OM and OA over and AM over here. So you can calculate OM and AM over here. So in this triangle over here, in triangle OAM, you have basically sine of omega. Sine omega is equal to AM to OA, is equal to AM to OA, which is equal to AM to OA is equal to P. So that means that sine omega is equal to AM to P. That means that basically AM is equal to P times sine omega. So that's one thing that we can use here. That's going to give you basically these two lengths that if you calculate them, that's going to give you the coordinates of this point A, which is, by the way, a point on the line. And you can use it in basically in this equation, y minus y1 is equal to m times x minus x1. Now in this equation, if you have your x1 comma y1, and if you have your m, you can write the equation of the line. So what we need to do is that we need to find the slope of the line, which is m, which we will do shortly, and we will also find the coordinates of one point on the line, which happens to be A in this case, which is basically, in this case, is the height of the point is AM, the distance of the point from the y-axis is OM, and we can calculate them this way. So then AM is equal to P times sine omega, and in the same triangle, basically cos omega is equal to OM over OA, which is equal to basically OM over P. That means that OM is equal to P times cos omega. Okay, So that is basically another thing. So the coordinates of the point A is, or basically are, basically the distance of the point from the y-axis, which is the x coordinate, is OM, which is basically OM comma AM, which is equal to basically OM is P cos omega, and AM is equal to P times sine omega. And now all we need to do is just find a way to find the slope of this line. And we know that the slope of this line is basically, we know that these two lines, OA and L, so the two lines basically L and OA, of course this is a line segment, are perpendicular. So you can say that the slope of OA times the slope of OA times the slope of basically line L is equal to -1, because they are perpendicular. So now the slope of the line OA is equal to tan omega, of course, because that's the inclination of the line. So that's tan omega. And the slope of the line L, I can just write it as, for example, M. That's equal to -1. So that means that M is equal to -1 over excuse me. That means that M is equal to -1 over tan omega, which is equal to basically -1 over sine omega over cos omega, which is equal to -cos omega over sine omega. And that's basically, the slope of the line L is -cos omega over sine omega. So now we can substitute these two values in basically in y minus y1 is equal to m times x minus x1. So the values are basically, your x1 y1 are basically these two coordinates, and this is your m. So you can write y minus p times sine omega is equal to -cos omega over sine omega times x minus x1, which is p times cos omega. So then y is equal to -p times sine omega, y minus p times sine omega is equal to basically -cos omega by sine omega times x plus basically p times cos squared omega over sine omega. Now if I multiply basically everything by sine omega, I'll get y times sine omega minus p times sine squared omega is equal to negative cos omega times x, or I can write it as negative x times sine omega, negative x times sine, I'm sorry, not sine, but if I multiply by sine omega, I'll get negative x times cos omega plus p times cos squared omega. And so I can write this as negative x cos omega plus y times sine omega, and then over here I can write negative p times sine squared omega minus p times cos squared omega is equal to 0. And if I multiply by a negative 1, I'd get x times cos omega minus y times sine omega plus p times sine squared omega plus p times cos squared omega is equal to 0. And so x times cos omega minus y times sine omega plus p times sine squared omega plus cos squared omega is equal to 0. So this is equal to 1. That means that x cos omega minus y times sine omega plus p is equal to 0. Or you can say that x cos omega minus y times sine omega is equal to negative p. Let me see in which way they have written this equation. I might have made a mistake somewhere over here, because this is supposed to be x times sine omega plus y. I see. I think I've made a mistake somewhere over here. Y minus 1 is equal to m times x minus x1. Y minus p times sine omega. P times sine omega is equal to negative, and the slope is negative cos omega by sine omega, and over here I have x minus p times cos omega. And so over here you can write y minus p times sine omega is equal to negative cos omega by sine omega times x, and here you need a negative sign. You need a negative sign over here, and then we need to rewrite the rest of this. Okay, I apologize for this, but anyway, you do need to write this as then if I multiply by sine omega, this is of course omega, so I'll get basically y times sine omega minus p times sine squared omega is equal to negative cos omega times x minus p times cos squared omega, and then you can write this as negative x times cos omega, which becomes x times cos omega plus y times sine omega minus p times sine squared omega minus p times sine squared omega minus p times sine squared omega. And then if I take this to the other side, now there's something wrong here. So if I have y sine omega minus p times sine squared omega is equal to negative basically cos omega times x negative p times cos squared omega. Okay. And then over here you have x times cos omega. This is negative. No, this is a positive, and this is positive. Okay. So then let me rewrite this part again. So over here I have basically x times cos omega plus y times sine omega is equal to p times cos squared omega plus p times sine squared omega. Now p times cos squared omega plus p times sine, so you can write x cos omega plus y times sine omega is equal to p times cos squared omega plus sine squared omega, and this is equal to 1. So that means that x times cos omega plus y times sine omega is equal to p. So in this formula, basically omega is the angle that the normal makes with the positive direction of the x-axis, and p is the distance of the perpendicular distance of the line from the origin. So x times cos omega plus y times sine omega is equal to p. So if we have x times cos omega plus y times sine omega is equal to p. That's the formula that we can use here in order to find the equation of this line. So now let's try the formula here. So over here I have, now over here my omega is equal to 30 degrees and p is equal to 5 units. P is equal to 5 units. Now basically sine 30 degrees, as you know, is equal to 1/2, and cos 30 degrees is equal to square root of 3/2. So I can write the equation of the line as x times cos omega, which is equal to cos 30 degrees is equal to square root of 3/2 plus y times sine omega. Sine omega is equal to 1/2 is equal to p, which is equal to 5. So if I multiply everything by 2, I will get square root of 3 times x plus y is equal to 10. Or I can say that question number 8, or I can say that the square root of 3x plus y is equal to 10, which is exactly the equation of the line that we were looking for. So once again, the formula is x times omega plus y times x times cos omega plus y times sine omega is equal to p. That's the formula that you need in such situations. So now question number 9. Question number 9 is the vertices of triangle PQR. So the vertices of triangle PQR, the vertices are P2, 1, Q is -2, 3, and R is 4, 5. 4, 5. You want to find the equation of the median through the vertex R. You want to find the equation of the median through the vertex R. So now if you draw your triangle over here, 2, 1 is going to be this point over here, and this is point P, 2, 1. The other point is -2 and 3, which is this point over here. This is -2, 3, point Q, and point R is 4, 5. So 1, 2, 3, 4, and 5. So that's this point over here. This is 4, 5, which is point R. Now if you draw this triangle this way, you will get this triangle. And the median through the vertex R. So just to be clear about the meaning of a median of a site, the median of a triangle, So in geometry, median of a triangle is a line segment joining a vertex to the midpoint of the opposite side, thus bisecting that side. Every triangle has exactly 3 medians, one from each vertex, and they all intersect each other at the triangle centroid. So that's basically what the median is. You draw a line segment from for example this vertex into the midpoint of the opposite side, and if you do so for all of the 3 sides, all of the 3 medians will meet at a point, whether inside the triangle or outside the triangle, but there will be such a point for each and every triangle, and this point over here is called the centroid of the triangle. So now the median through the vertex R is going to be, for example, let's suppose that this is the midpoint of this side, and this is the median. So now you want to find the equation of the median through the vertex R, which is essentially the equation of this line. So what you need to do here is basically, this line has basically 2 points. One of the points is 4, 5. The other point is the midpoint of these two points. So the midpoint of PQ is equal to basically -2 plus 2, -2 plus 2 divided by 2, and then 3 plus 1 divided by 2, which is equal to 0, 2. So basically the coordinates of this point is 0, 2. So now the line that I'm looking for has basically these 2 points, 0, 2 and 4, 5. If I take these 2 points and use it in this equation over here, y minus y1 is equal to, for example, m times x minus x1, and if m is equal to basically y2 minus y1 over x2 minus x1, I will get basically my m is going to be equal to basically 2 minus 5, 0 minus 4, which is equal to negative 3 over negative 4, which is equal to 3/4. And so the equation of the line becomes y minus, I will choose this point for example, y minus 2 is equal to basically 3/4, which is your m, times x minus x1. x1 is equal to 0, so times x. So what that means is that but then you can write y is equal to 3/4 x plus 2, and that is the equation of the median of that triangle through vertex R. So question number 9 is 3x minus, or you can write it as, for example, 4y plus 4y is equal to 3x plus 8, and negative 3x plus 4y plus negative 3x plus 4y negative 8 is equal to 0, and then 3x minus 4y plus 8 is equal to 0, which is the exact equation that they have gotten in the book. That is the equation of that median. Okay. So this was question number 9. We have a couple more questions here as well. Okay, so the next question that we have is question number 10, which is find the equation of the line passing through negative 3, 5, passing through negative 3, 5, and perpendicular to the line through the points find the equation of the line passing through this and perpendicular to the line. So basically the line is passing through this point, and another point, let's call it for example x2, y2, and this line over here, if I call it for example L1, it is perpendicular, L1 is perpendicular to L2, and basically L2 passes through 2, 5 and negative 3, 6. So what I need to do is that first find this line L2. Once you have that line L2, using line L2 you can find the slope of the line L1, and then we can find the equation of the line L1. So now basically 2, 5 and negative 3, 6 basically to find L2. So your m over here is equal to basically 6 minus 5 over negative 3 minus 2, which is equal to 1 over negative 5. And so y minus y1 is equal to m times x minus x1. I take, for example, this point over here, 2, 5. And so I can write y minus 5 is equal to negative 1/5 times x minus 2 times x minus 2. So y minus 5 is equal to negative 1/5 x negative positive 2/5. And so you can write y is equal to negative 1/5 x plus 2/5 plus 5. Now 2/5 plus 5 is equal to basically 5 over here, so 2 plus 25 is equal to 27/5. 27/5. So negative 1/5 x. So that's the equation of the line. That is the equation of the line L2. This is the line L2. Now, since we said that, since L1 is perpendicular to L2, therefore M1 times M2 is equal to negative 1. So now over here, your M2 is equal to negative 1/5. So that means that M1 times negative 1/5 is equal to negative 1. You can cancel these two out, and that means that M1 over 5 is equal to 1. That means that M1 is equal to 5. That means that M1 is equal to 5. So now to find this is a T, of course. To find L1, M1 is equal to 5, and a point on the line M1 was negative 3, 5. Was negative 3, 5. So you have y minus y1 is equal to m times x minus x1. So y minus 5 is equal to 5 times x minus x plus 3. So y minus 5 is equal to 5x plus 15, or y is equal to 5x plus 20. That is the equation of the line that we were looking for, which was basically question number 10. 5x minus y plus 20 is equal to 0. Okay, so the next question that we have is question number 11, and that is basically, the question is a line perpendicular to the line segment joining the basically 2 points. So let me draw a diagram here. 231. So we have 2 points over here, 1, 0, 1, 0, and 2, 3, and 2, 3, and these 2 points are over here. So this is 1, 0, and 2, 3. Now, if I join these 2 points, I will get this line segment. Now, I have a line that is perpendicular to this line. I have a line that is perpendicular to this line and divides this line in divides this line internally. This is x and this is y. Divides this line internally in the ratio 1 to n. In the ratio 1 to n, meaning that if I call this point A, for example, and if I call this point B, and if I call this point C, then I can say that AC to BC is equal to 1 to n. That means that this line segment, this line, basically call it L, for example, this line L is dividing this line segment AB internally in the ratio 1 to n. So now we want to find the equation of this line L. So to find the equation of the line L, we need, basically we can use y minus y1 is equal to m times x minus x1. So over here we need basically the slope of the line, and we need some point, for example x1, y1. So for that point we can use the point C, and based on the slope of this line segment AB, I can calculate the slope of the line L, because the two lines are perpendicular. So that's what I'm going to do. So now I need to find the coordinates of the line of the point C. And to find the coordinates of the point C, what I need to do is basically we said that if a line divides the line segment joining, basically the line segment joining the points basically x1 comma y1 and x2 comma y2 internally in the ratio m to n, then the coordinates of the point of intersection, let me see what this was. Come over here. So that the coordinates of a point, well, you can say that you can call it a point, for example. It doesn't really have to be a line. I can say that, for example, if a line divides the line segment joining the points x1 and these 2 points internally in the ratio m to n, then the coordinates of the point of, for example, the point of intersection of the two lines, of the line and the line segment, basically then the coordinates of the point of intersection of the line and the line segment is or are basically this. Or you can simply, to simplify this, you can say that if a point divides a line segment joining these 2 points internally in the ratio m to n, then the coordinates of that point is going to be basically this. That's basically 2 ways of saying the same thing. So the formula is basically m times x2 plus n times x1 over m plus n, and over here we have m times y2 plus n times y1 over m plus n, and that is basically the coordinates of that point. Now I can use this concept over here in order to find the coordinates of this point C. So over here we have the 2 points are basically 2, 3 and 1, 0, and then the ratio is 1 to n. So that means that the ratio is 1 to n. You can take this as m and you can take this as n, what you have in this formula. And the points are basically 1, 0 and 2, 3. So then the coordinates of this point C are going to be basically m times x2, so 1 times x2 is equal to 2, plus n times x1, which is equal to 1 times n, which is equal to n, over m plus n, which is equal to 1 plus n, 1 plus n, and over here you have m times y2, 1 times 3, which is equal to 3, plus, and of course it's always a good idea to actually write down all of these, because this way you do, most of the time you do make mistakes. So you want to, it would cost you one more step, but you're sure that you haven't made any mistakes. So I write basically, for example, m is equal to 1, and x2 is equal to, for example, 2. This is much, this way you can make sure that you haven't made any mistakes. And over here I have n times, for example, x1, which is equal to 1. And m plus n is equal to, of course, 1 plus n. And the other part is m times y2, so m is equal to 1 times y2, which is equal to 3, plus n times y1, which is equal to 0. And you want to divide that by the same thing, 1 plus n. So these are the coordinates of the point C, which is the same thing as basically 2 plus n over 1 plus n, and this over here is basically 3 over, this is 0, so this becomes 0, 3 over 1 plus n. And so basically now you can use basically, now this is the point that we were looking for. Now the next thing that we need is the slope of this line L. And well, we said that basically since these two lines are perpendicular, based on the slope of this line I can find the slope of this line. So what I'm going to do is that I'm going to basically find, first I'm going to find the slope of the line segment AB. So the slope of the line segment AB is equal to basically y2 minus y1 over x2 minus x1, and these are the points. So you can write it as basically 3 minus 0 over 2 minus 1, which is equal to 3 over 1, which is equal to 3. Now if the slope of AB is equal to 3, then I take the slope of, and I call this, for example, m1. I take the slope of this line L as m2, so then I can write m1 times m2 is equal to negative 1, because they are perpendicular. Because they are perpendicular. Or I can say that, to be more precise, I can say that L is perpendicular to AB, basically. So what that means is that then now my m1 is equal to 3, so 3 times m2 is equal to negative 1, so m2 is equal to negative 1/3. and that is the slope that we were looking for. So now we know the slope of the line, and we know one point on the line, so we can use this formula y minus y1 is equal to m times x minus x1 to find basically the slope, the equation of the line. So I write it as y minus y1, which is equal to basically 3 over 1 plus n, is equal to m negative 1/3 times basically x minus x1, which is equal to 2 plus n over 1 plus n. So this is the same thing as y minus 3 over 1 plus n is equal to negative 1/3 x. Negative into negative is positive. So that's 2 plus n over 3 times 1 plus n. And then you can what you can do is that you can multiply both sides of this equation, every term, by 3 times 1 plus n. So 3 times 1 plus n times y minus 3 times 1 plus n over 1 plus n is equal to negative 3 times 1 plus n over 3 times x over 3 times x plus 3 times 1 plus n times 2 plus n over 3 times 1 plus n. So then over here I have 3 times 1 plus n times y, and over here I have 1 plus n, so that's negative 9 is equal to 3 and 3 cancel out, negative 1 plus n times x, and these two will be cancelled out, so you have plus 2 plus n. And this is, by the way, this is x. So you have, basically I take this to the other side, I will get 1 plus n times x plus 3 times 1 plus n times y is equal to basically is equal to 2 plus n plus 9. So 1 plus n times x plus 3 times 1 plus n times y is equal to n plus 11, which is incidentally also actually the right answer. So this was question number 11. 18, I suppose. This was question number 11, no, number 12. And the equation of line that cuts off, no, 11 is 1 plus n times x plus 3 times 1 plus n times y is equal to n plus 11. That is the right answer. So we have still basically question number 12 through 20 that we will get to in the next videos.